Here we go. Section 10.3 on arcs and chords. Now in class you did miss cutting and folding activities which demonstrated what these theorems, relationships that these theorems are referring to. So for the notes, really just try to follow along and watch the vocabulary as we go through it. All right, theorem 10.2. Let me demonstrate it using the given and the proof here. You'll notice that they give us that segment AB is congruent to segment CD. Now, if that is the case, think about it, that if those two are congruent, that means if I cut along the chord, you'll kind of see that I'm slicing the circle along the same length. In so doing, because this is the same circle and it's from the which is made up by or using the same exact center point, then you will find that the arcs will be congruent as well. So if you're given segment AB is congruent to segment CD, then you can go ahead and say that arc AB is congruent to arc CD. Hence, we have our theorem, and it states, in a circle or congruent circles, two minor arcs will be congruent if and only if their corresponding chords are congruent. The if and only if means that you can take that statement, switch it around, and it will also be true. So say, for example, and if you need further examples, they are in your textbook, but let's say that they tell you that the length of this arc is 70 degrees, and you know that these two, one more time, these two chords are congruent, then you can automatically assume that this arc formed by chord CD is going to have the same measure and will be congruent as well. Now on to theorem 10.3. If you take a look at what's happening in this diagram, you will notice that this diameter AB, given to us by the right angle drawn there in red, is going to be perpendicular to chord CD. So if you know that a diameter AB is perpendicular to the chord, as you can see from my markings, you know that the segments will be congruent. Segment CE will be congruent to ED, and the arcs will be congruent as well, because, as stated in theorem 10.3, in a circle, if you have a diameter or a radius which is perpendicular to a chord, you will find that it bisects that chord. In this case, bisects it into segments CE and ED, and it bisects the arc CB and BD. Only one more theorem to demonstrate. On this one, I can kind of do with you on the side. Let's take this circle. And let us take this chord and this chord. Do you see how this chord, the upper left-hand chord, is smaller than the larger bottom chord? What is the reason? Well, it all has to do with the distance from the center. Please notice, as you take this segment and move it away from the center, you're getting closer and closer to the circle, hence your circle's closing, hence your segment will be shorter. So what does that all mean? Well, let's take a look at our example here. You can see in our diagram, they have marked for us that segment AB is congruent to segment AC and is perpendicular to, representing the distance from a chord to the center point. So therefore, if it is equidistant, that means your two arcs will be congruent as well. So the final theorem in this section states in a circle or congruent circles, two chords will be congruent if and only if they are equidistant to the center. That closes this mini lesson for today. If you wish to see any examples, please look at the examples in the section, and make sure you have your homework completed, the homework that is listed above. Until next time, I bid you adieu.